Recording is rolling. It is Friday, August 22nd. That trigonometry and 10 triangles page. A lot of you guys just turned. You guys see this gray tray right here? You guys see gray tray? Right, so a bunch of guys just turned that into the gray tray. I'll be grading those over the weekend. It's two separate assignments that will show up in your focus. Okay. Okay. You guys know we're on a pep rally schedule today, so we got a little bit shorter classes, pep rally today. So that's nice. Here's a bonus thing. So I know we've been talking a little bit about vector. I mean, that relates to trigonometry, right? Vector components. Okay. So, guys, this slide I just did yesterday. This is not in any files you have so far because I figure out I actually need this one. I need to kind of lay out these definitions. So there are two types of quantities in physics, right? There are vectors and scalars. So a vector has a magnitude and a direction to it. For example, you could have a force of 10 newtons of force, right? Or how about any of these? A displacement can be a type of vector that can be in meters. Right? Velocity, like the speed, that can be in meters per second, or miles per hour for that matter. Right? Right. We're just starting talking about acceleration. Do you guys kind of figure out what acceleration is, sort of as a concept? What is that? Yeah. Okay.
Like a change in the speed.
Exactly. Yeah. Like a change in velocity. It's a rate change in velocity is what it is. Right. It's how fast you're changing your speed. Ooh, a rate change in velocity. We'll tag a little formulas to that probably next week. Right. Okay. Like a force is actually my example here. Probably these other ones: momentum, torque, angular momentum, which we'll get to way later in the year. But yeah, those are all they all have magnitudes and directions. Right. Yeah. The other category of quantities you'll have are called scalars. This is something that has a magnitude. For example, you could quantify mass and how many kilograms is that, but it does not have a direction associated with it. Hey guys, is there a direction of mass? No, right? If it's just floating out in the middle of deep space, it can still be 1 kilogram. It just doesn't really have a direction. Now, a weight. Ooh, guys, does weight have a direction?
Yeah.
Yeah, weight straight down. Right, but weight's a type of force. Right, so that's there. How about now? Look real close here. Displacement versus distance. So it's a little technical difference. Okay? Here, actually, let me talk about that right now. Okay, suppose you start on the left side of this page, and you go all the way to the right, and you go back to the left again. All right, you guys ready for this? You guys ready for this? This is a tricky thing. AP could totally ask this question. So you start right here. Here, I got a little toy car. I start on the left side. I go all the way to the right side of the paper. You go back to the left side of the paper. From the beginning point to the end point, guess what your displacement is? Zero, like 0 centimeters. Right? Now, suppose how wide is this paper? About almost 30 centimeters. Guys, if this car went 30 centimeters to the right and then 30 centimeters back to the left, right, guess what total distance the car went on its odometer? 60 centimeters, right? Okay, you guys get that? Okay. What if it goes around in a circle and it ends exactly where it starts? What is its displacement? Zero. But would its distance travel be like 2 pi r?
Yeah.
Right? Okay. All right. How about volume? That doesn't have a direction, right? Okay. Time is usually considered to be also a scalar. I know, kind of goes forward, but speed as opposed to velocity. Yeah, a little technical difference. If you see these words in a physics textbook, speed, they're just talking about like how fast is magnitude. Okay. Okay. All these other ones also don't have direction. All right. So you guys get with vectors versus scalars. Okay. There's kind of doing this one already. We'll be doing this more. This page out of the if you download the book file, the PDF. I did have to fix this column right here. It should be t squared, which some of you guys did yesterday already, or you're in the middle of doing right now. A little amendment right there. Let me spit. All right, so back over here then. All right, so you guys have the rest of class pretty much to finish gathering any data you need to gather, because all that equipment, a lot of equipment is there from yesterday. If you need time to draw your graphs, good opportunity today. You guys remember I split you guys up into 4 different experimental groups. You guys remember those card suits? You got clubs, spades, diamonds, and hearts. And from that, you're able to make these different types of graphs. So, for example, if you have the spades, you can actually create both of these graphs. Distance versus time, or displacement versus time, if you like. Okay, and also make this one. You guys see displacement versus time squared in square seconds? Right. Now, this is an abstract idea, but once you guys see the graph, it'll make more sense. Okay. So you'll be able to create 1 or 2 graphs today, and then on Monday we're gonna put all the graphs together, okay? And you'll see all the graphs, and we'll come up with like a master equation to describe how the car goes on the incline. Okay, guys. Also, write up. You guys remember I was having you do the AP style write up? Ooh, do I have page in front? Right. Guys, remember that AP style write up with the very specific format that AP is looking for. Here it is. Here it is. Okay. So, basically, I'm just reminding you guys this. You guys are going to do this quite a few times throughout the year, and then, of course, on the actual AP exam. Okay. So, there's some question you're trying to answer, and there's actually, I guess, 4 questions floating around right now, depending on which seat you have, which card seat you have. Okay. What equipment did you use to measure? Like stopwatches, meter sticks. Okay. Procedure, briefly describe setup, which could be a sentence. Okay. Set car and incline, let go. We've done. Okay. What measure tools you use to measure which variable? Okay. What's your independent variable, dependent variable, and controls? Make sure whoever's reading your write up, it's very clearly stated. Right? You guys see this whole thing could just be like a few sentences, right? I'm not looking for like a 5-paragraph out there or something. Just a few sentences. That's all. Okay. Okay. And then always mention this though. Always mention, oh, I did multiple trials to reduce experimental uncertainty. So I did 3 trials and an average, 3 and an average, 3 and an average. Okay. Especially if it's not. Okay. Analysis is going to be the graphs. So you guys are drawing the graphs right now. And conclusion, make sure you answer the question that you started with. Remember, there's pretty much 4 questions floating around right now. Okay. What's distance versus time is one of the 4 questions. Okay. So it goes back to those card seats. Okay. 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 Guys good? Okay. Here, the 4 questions I'm talking about. 1, 2, 3, 4. Those are your 4 questions that we're trying to model. What else here? Oh, puzzles. Right. So I did post to Google Classroom some files recently. I want to guess rolling on. You guys know this whole car and incline lab is an introduction to linear motion, right? How do things move in straight lines? Okay. But I like to kickstart these sections with labs so that you kind of discover things yourselves. Because once you discover things, then you read it, look like, oh yeah, that's totally what I did in lab. Okay, you see how it connects. Okay. So I'm going to put this in your hands today. So on one side, these are textbook puzzles straight from your textbook. Okay. So I went through your textbook. I found my favorite questions and I scanned them. And yeah, here. Okay. On the opposite side are some classic questions that I've been using for years. If you sort of keep track of how many category questions can you ask, before you kind of exhausted all the questions, this pretty much covers all the bases of every type of question that you could possibly see that you could solve with a basic equation. Okay. Okay, so I don't expect you guys to be able to solve these quite yet, but you start reading these, then next week as we get going, you'll be able to do those. Okay. And I'm planning a quiz for next Friday. Well, I have that on the board, so just kind of anything we've done in class so far. I'm trying to do something a little different this year, so anything we've done this week or for Monday, Tuesday, Wednesday, kind of look for on the quiz. Okay. All right, any questions about anything? All right, so you guys got the rest of class to get any lab data you need, make graphs, do that AP style write up. All right, and I'll walk around and help you guys.